Day 14 of 90, and today we build something every C++ developer should write at least once, a student grade system. Sounds boring? It isn't. This tiny project is a trap that exposes exactly which ownership rules you haven't internalized. We'll start with a version that compiles perfectly clean and still leaks memory on every file save. Then we'll fix it with RAI, kill duplicate code with one template, and move an entire semester of grades with 0 heap copies. Stick around, each section is a chapter, so jump to whatever you're stuck on. Here's the broken version. We allocate students with raw new, student * roster equals new student, count. We read grades, then somewhere in the middle we hit bad input and write return. See the problem? That early return skips delete, roster entirely. The array is gone, the pointer is gone, the memory is still allocated. Run it under Valgrind and you get definitely lost, 4096 bytes. It compiles, it runs, it even gives correct grades, and it bleeds memory every single time validation fails. The fix is ownership. Replace the raw array with std unique_ptr student, roster, new student, count. Now when that early return fires, the unique_ptr's destructor runs automatically and frees the array. No delete call anywhere in your code. The leak is impossible, not patched, impossible. And notice the calling code barely changed, you still index roster, exactly the same way. That's the whole point of RAI, to tie the resource's lifetime to a stack object, and the compiler handles cleanup at every exit path, including the ones you forgot. Let's make this a real class. Our gradebook holds a std, a vector record, and a save-to-file method. Inside save, we open std offstreamout path. If writing throws halfway through, that stream's destructor still flushes and closes the file, versus a raw file asterisk that you'd leak the instant an exception unwinds past your close. Now, the rule of 5. Once your class manages a resource, you owe the compiler 5 members: destructor, copy constructor, copy assignment, move constructor, move assignment. With a vector member, the defaults are actually correct, so you write equals default and document the intent. The lesson: know the 5 exist, decide deliberately, don't let the compiler guess silently. Add bounds checked access. Overload operator, to call vector at, which throws std out_of_range instead of walking off into undefined behavior. Now an off by 1 is a catchable exception with a message, not a silent crash 3 functions later. This is the correctness stake nobody mentions in tutorials. A grade system that reads garbage memory might report a passing grade for a student who failed. Bounds checking isn't pedantry here, it's the difference between a bug and a wrong transcript. Now templates, where they actually earn their keep. We need statistics, mean, median, top n, for exam scores stored as vector int and weighted scores stored as vector double. The wrong move is writing 4 overloads. The right move is one function template dependencies t-stats t-compute_stats, const std a vector t-grades. It returns a stats t struct with mean, median, and a percentile. Call it once with your int vector, once with your double vector, same code, the compiler stamps out both versions. One template replaced 4 handwritten functions, and adding a float grade type later costs you exactly 0 new code. That's when templates reduce complexity instead of adding it, when the logic is identical and only the type varies. Last piece, move semantics. Picture a semester struct holding a vector grade record, thousands of entries. At year's end you archive it, archive.push_back, std move, current semester. Without the move, you copy every record to the heap, then destroy the original. With std move, the vector's internal pointer is just handed over, the archive takes the buffer, the source is left empty and valid, and the heap allocation count stays flat. Wrap your allocator in a tiny counter and print it, copy. Version shows thousands of allocations, move version shows 0. That visible number is the moment move semantics stops being abstract. Day 14 done. Your takeaway: every resource gets an owner, and that owner cleans up automatically. Raw new and raw file asterisk are where leaks hide, RAI and unique_ptr make them impossible, one template kills your overloads, and std move transfers without copying. Build this grade system yourself before tomorrow. The bugs you hit are the lesson. Subscribe for day 15.